Welcome to our IT Pros Today webcast, using community-driven threat intelligence to improve your security, sponsored by Snapt. If you have any technical difficulties during today's session, please press the Help widget on your player console to receive assistance in solving common issues. If at any time you are having audio difficulties or issues with the advancing of the slides, please hit your F5 key to refresh your webcast console. Today's web seminar is being recorded and will be available on demand for 12 months starting tomorrow. You will receive an email when it is ready. Please feel free to submit any questions you may have for our speaker in the Q&A widget. Our speaker today is Frank Yu, Principal Solutions Architect and Product Evangelist. And with that, I'll hand things over to Frank.
Thank you very much, and thank you everybody for joining this presentation. Good morning, good afternoon, and good evening based on where you are, since we are in a digital global world nowadays. And as mentioned, today's topic is using community-driven threat intelligence to improve your security. And this is a very important topic for us to discuss and understand and get better handle on, because when we talk about cybersecurity and security in our IT infrastructure, it's all about getting information to determine what actions, what policies, what rules you want to apply to your systems. You don't know what you need to do until you get information to determine this is a threat, that's an issue, or I have a vulnerability here that I was unaware of. And how do we get that information? I mean, traditionally we look at, things, we look at our firewall logs. If we have firewalls, we look at our web server logs, we look at other pieces in our network, and we might have lots of invested in a lot of tools and things like that to try to figure this stuff out. But it's complicated, it's hard, and we still miss a lot of information. And we'll talk about like recent examples in terms of what this means, what this can cost you, how can you do things to help mitigate things. So let's move along in these slides and let's start talking about this. So like I mentioned, managing cybersecurity is a challenge. Oh my gosh, is it a challenge? I've been dealing with IT for too long, for close to 30 years now. And hacker tools continue to evolve. I mean, a good case in point, back in the old days when I was a kid, and I'm showing my age, when our concept of hacking when I was a kid was what we called phreaking. And you may not know what phreaking is, maybe you do. But what we did is we were trying to take advantage of the phone systems to get around things. For example, we would use tools or devices to generate tones for payphones, make it sound like we were entering coins, or the tones that were generated after you entered a coin, so the operator on the other end of the payphone would think that you have dropped 10 quarters in. So now you are okay to make a long distance call for 2 minutes. This was what we called phreaking. And that's what we did back then. What we do nowadays today is so completely evolved with the IT infrastructure stuff. But going back to the phone world, now what we're doing is we're trying to hijack PBXs, voice over IP systems. And why would we want to do that? Well, there's lots of good reasons. One is there might be good information on it, such as, directories of people and their phone numbers, voicemails. Wow, how many movies and TV shows have I seen where they have gotten voicemails that were incriminating? In real life, how often does that happen? Or even better, as a hacker, I could use the phone system, once I hijacked it, to make it look like I'm coming from the internal company system calling someone, so I am now more credible. So when I ask them information in, like, oh, I'm working for IT security and we had a problem with our mail server, we need to reset your password. What's your current password? They're more likely to tell me. So the tools are evolving rapidly, and even nowadays, Another great example was we used to do all this stuff, I'll say manually. We had scripts, and we had the nickname of script kiddies to people who use scripts to do things that were kind of automated. But man, nowadays we have botnets. We have this army of automated engines, thousands, millions of these things doing things on our behalf to try to find the vulnerabilities, to break into systems, get information, and they're doing the job for me. Wow. New vulnerabilities are found. No matter how diligent you are, you will not be able to protect your systems 100% for the rest of your life. It's just flat out impossible, and I challenge anyone to prove me wrong. Vulnerabilities are constantly being discovered, and there's always a way around systems to try to figure out how to get into something. There's a YouTube channel that I follow regularly, Lockpicking Lawyer. Very cool. He's a guy, and he shows you how to lockpick and open basically every single lock on the planet, and how easy it is, at least for him. It's not for me. I'm not as good as he is. But no matter how well you design that lock or vault or combination or safe or whatever it is protecting your data in your system, somebody is going to find a way around it. So you can protect as much as you want, a new vulnerability can be found. So now I have to add a new layer of protection, a new rule, a new policy to protect against that vulnerability. We've seen that in the past week with this most recent one that we've discovered that we'll talk about. And the third point here is cybersecurity is a challenge because these IT architectures are getting really complicated. When I started working in IT and managing and designing networks, excuse me, they were fairly simple. I had routers, I had switches, I had servers, I had an internet connection connecting to my data center, and I connected it all together, and boom, it was fairly straightforward. In, out, things worked. We evolved, we get more complicated, we start adding technologies like IPS, load balancing, disaster recovery. And then we start adding things like virtualization, software-defined networking, public cloud, private cloud. Now we have containers and orchestration systems like Kubernetes and microservices. And it was easy back in the old days because I knew the exact path of how things went from A to B. And I knew where to put my blockers and my gates and things to be able to protect that, my services. In today's world, who knows where it's coming from? Who knows where it's going to? Because we have these clouds and multi-cloud and virtualization, and things are being spun up and spun down all over the place. By the way, that picture, someone I was working with that I was working this presentation on, that's a real apartment complex. That was designed it was actually designed in Montreal for the 1967 World's Fair. Wow. I cannot imagine living in one of those top apartments or condos or whatever they call them and figuring out how to get there every single day, in and out. But that's what our IT architectures have become. They become this complex mess that we cannot it's just almost impossible for us to manage manually today and understand how things are moving from point A to point B. So how do we apply cybersecurity if we cannot understand how the things are laid out? I think the best way for us to start looking on how we do things and collect this information so that we can apply our cybersecurity policies and define them and put them into practice so that we protect our assets is looking at, I put air quotes on this, at the real world. How do our intelligence agencies work? How do they collect information and determine what is useful, what is not useful? So let's take a little dive into the world of the intelligence agencies. And it's kind of cool because now you're looking on the backside of all this information. And I'm going to use the example for the United States. Partially because I live in the United States, I have more intimate knowledge of how it works in there. and we'll discuss that over a beer sometime if you want to, maybe. But just keep in mind that the rest of the world and other organizations and countries, the European Union, other countries in Asia, Australia, they have a very similar model. So in the United States, we have two main organizations: the Central Intelligence Agency, the CIA, which most of you know or are aware of at least because you see them in the movies all the time, obviously, and the Department of Defense, the military arm. Excuse me. In the Central Intelligence Agency, we have two main groups. We have the Directorate of Operations. This is the people in the field collecting the information, doing the human intelligence, getting the informants, doing the sneaking around, collecting information. This is your James Bond. James Bond works for MI6, the British version of the Central Intelligence Agency. But this is your James Bond or whoever that's going out and doing all these cool, at least it seems cool in the movies they do, things to gather this information and determine what the data is, what is happening. Talk to my informants. Get cozy with these people, these organizations. Go in and steal some information, whatever the case may be. And then you also have the Directorate of Science and Technology, DS&T. This is your technology arm. They do a lot of the research, collection, processing, and analysis, but they also do a lot of the technology. So referring to the movies again and referring to James Bond again, this is like your Q branch. They make and work with all these cool tech tools to collect and process and identify the information. And now we have the Department of Defense. And the first and the biggest one that everybody knows of, which they didn't know of until kind of recently, is the NSA. The NSA is the super secret organization, as everybody knows. The acronym NSA, also some people refer to as no such agency, because they don't want to be known. They want to be out of the limelight for good reason. The NSA has the responsibility for establishing and operating all the intelligence activities for the Department of Defense. And they do things in terms of collecting intelligence. So when we talk about things like tapping the internet and doing this, and the government knowing about everything that you're doing on the internet and this big brother type concept, that would be the NSA. They do a lot of interesting things that we can and can't talk about in terms of the collection of this information and gathering it. So they do similar to what the CIA does, but excuse me, more on a technical perspective and more dealing with getting things from a foreign activities perspective. Excuse me. Then we have the the Defense Intelligence Agency. Defense Intelligence Agency, they don't as much collect, but they're the analysts. They're the ones that take all the information and determine what is useful, what is not useful, and what is important, and how this all comes together to provide actionable information. And we'll talk about actionable information because that's an important point we want to make. The National Reconnaissance Office, they do all the satellite stuff, all the space missions. So all the satellite imagery that you see in the satellite photos and things like that, that is the National Reconnaissance Office. And then correspondingly, we had the Defense Airborne Reconnaissance Office. They do the things from airplanes, the SR-71 Blackbirds, all the surveillance aircraft, whether it's manned or unmanned. They do all the surveillance from the aircraft. So they work obviously with the Air Force in the United States to collect all this information. And then we also have the Central Imagery Office. And they coordinate the image collection, standardize it. So when we have satellite photos from the airplanes, and we might have photos from people on the ground and other pieces, they coordinate and standardize to make sure it all makes sense. And then lastly, within the Department of Defense, each of the branches, the Army, the Navy, the Air Force, the Marine Corps, they have their own little groups, like the SEAL teams and Delta Force and those things, where they're not only actions where they do the cool stuff you see in the movies, but they're also doing a lot of data collection. So the main thing that we see here is there's a lot of different sources of information, and they provide different pieces of information to give you a big picture. And that's what we need for cybersecurity. We need to be able to take lots of different pieces of information, which may on the surface seem unrelated, but then bring them together to find the correlation between the different data points. And when we talk about the information, let's talk about the different types of information we're gathering, because this is important. First, we have human source intelligence. The intelligence agencies are gathering information from people. So this is your confidential informant. This is your people in the field talking to them and gathering and collecting information in the field, or human related, whether they're papers and documents or pieces like that. A lot of that can be human source intelligence. The second piece is signals intelligence. In the IT world, this is what we usually think of. So these are internet communications, data taps, logs on the firewalls, metrics or statistics that we see on our network devices, logs on the web servers, etc. All this is signals intelligence. So when the NSA is tapping the internet connections, that's considered signals intelligence. Imagery intelligence. It is what it sounds like. It's the use of pictures, images, in various forms, whether they're standard physical pictures, or they could be infrared or radar or other technical based pictures, and they give us an insight as well. And the last piece of intelligence that they gather is what they call measurement and signature intelligence. In other words, it's information that's been partially analyzed, where in this case, you can see there on the text, nuclear explosion. The nuclear explosion happens. How do we know the nuclear explosion? Somebody did a test of a nuclear warhead somewhere underground, because we see the impact in terms of the earthquakes. We know what it looks like in terms of what it should look like in terms of the data that we're seeing in terms of earthquakes, other types of movements, air changes, whatever the case may be, to say that, okay, we know that nuclear explosion happened in this place because we saw all this corollary data. So this is what the intelligence organizations gather. They gather all these different types of data. And again, correspondingly, we need to be collecting data from all these different organizations and types of data to be able to properly position ourselves from a cybersecurity perspective. So what do they do with all that data? How do they deal with it? Again, there's a lot of different groups and agencies. You can see there's a lot of pieces to the pie. It's not just gathering information, processing, and spitting out. There's multiple organizations involved. So first is the National Intelligence Council. It's part of the CIA, and they do all the analysis. They do the analysis of all the data. So these are the analysts sitting in the rooms, and they could have automated processes as well, and I'm sure they do. In fact, I know they do. Don't ask me how. And they collect all this information, process it at certain levels and certain triage levels, determine what makes sense, what are the correlations, is there something happening because I see this data point from this one source from human intelligence, I see another data point coming from my satellite imagery, I have another data point coming from this other source from this location, and bring it all together and determine what that is. That's what the analysts do. We have the CIA's Director of Intelligence. They do all of this analysis for the CIA and bring it all together. We have the Department of State. They have a Bureau of Intelligence and Research. Their job is to provide information, take all this information, gather, and provide it to the government officials, Department of State, and other officials within the government organization. So when you hear about things like these daily briefings that they give to the President of the United States, a lot of that will be based on these types of reports. And then within the Department of Defense, we have the Defense Intelligence Agency. Similar concept, they are doing the analysis of all this data. So all this information coming from all these sources, as well as the different military branches, then gets accumulated and processed. And within that, you have it on a regional basis. So in the United States, globally, we have 9 unified commands. Atlantic, Central, European, Pacific, Southern, Space Command, which is relatively new since we now have the Space Force, which is now the 5th arm of the military. Special Operations Command, Strategic Command, and Transport Command. So all of them have their own reasons and interests in the data, and they want to look at different things. Similar thing within your organization. If you have a large organization, your financial team cares about some things, while your HR team cares about other things, while your business continuity, if you're e-commerce and your web server team, they care about different things. So they don't all care about the same threats and issues. So they need to focus on what is important for them. And of course, the last 2 pieces for the United States, we have the Department of Energy, which covers a lot of the public resources. So in terms of electrical grid, nuclear power plants, things like that, and Department of Treasury, of course, which covers money and the financial transactions and pieces. So it's all very complicated. But for what it's worth, this government and other governments have done a pretty good job over the years of putting together and making heads or tails so that we can have actionable threats. This is why we don't have these attacks and terrorist attacks and what have you happening on a daily basis, because they are doing the legwork in advance to stop them before they happen. So they are stopping that zero-day attack by using intelligence that they're gathering beforehand. We want the same model for our cybersecurity. We want to be able to stop the attacks before they actually occur, because we know they are going to happen, or we see models that are similar to what they're doing. So let's talk about how all this really does map to cybersecurity and what we do in the IT industry, and what can we do in the IT industry. First, said it before, saying it again, keeping up is hard. You have multiple data points that you need to deal with. My IT infrastructure is not trivial. I have my front-end public-facing web servers, my corporate servers. If I'm e-commerce, I'm going to have my e-commerce web servers and my shopping carts and my database, my customer database. I have financial systems. I have my HR. I have all these other pieces and processes, whether cloud-based or hosted in my own environment. And managing all that and determining the threats, and it's overwhelming. Your head is going to explode trying to figure all that out. And on top of that, all the data that you're going to collect has to be timely. If all your information is a year old or 2 years old or even a month old, you're going to have problems, because the landscape is changing constantly, as we mentioned, and new threats are going to be popping up constantly. We're going to have situations like recently, and we'll talk about, vulnerability got exposed in the past week or so, and it's affecting millions of websites worldwide, and everybody's jumping on it. So if you haven't seen or aren't aware of the news about this vulnerability, for web server vulnerability, do a quick search of your various security documentation or information resources online, and you're going to see it's all over the place. Search for log4j, and you will see what is happening. So you need to have timely data, and you need to have relevant data. Just collecting data just because is not useful if that data is not meaningful. Not all data is going to be useful, but you want it to be meaningful at a certain point in time. If all you're doing is collecting junk, as the old saying goes, garbage in, garbage out, you're going to get junk. You need to collect useful, relevant data. And the last and the biggest piece of this, and the secret sauce for a lot of places and a lot of organizations, is the analysis of this data. That's where the magic happens. Collecting data, depending upon how you do it, doesn't necessarily have to be that hard, but making heads or tails of it using some sort of system to analyze the data, especially if you're collecting a lot of data points, you need to have some sort of automated engine, whether you call it machine learning, artificial intelligence, AI, whatever the case may be. You need to be able to analyze that data to understand, is this a credible threat or not? So taking care of all these points is challenging. Ultimately, again, cybersecurity starts with information. It's like, as you can see in the picture, it's like an interrogation. I'm interrogating my resources, my web servers, my devices, my security devices, my firewalls, my other components. I'm interrogating the internet. I'm interrogating people that have resources similar to mine, if I can. I want to be able to collect all this information to make these correlations. So I want to know what are the potential threats? What is out there? Who's being attacked? What is being seen? I can use news sources for that. I can use other sources. Who are the possible attackers? Where are they coming from? Is it some organization out of Russia? Is it some organization out of China? Is it some organization out of the United States that's doing this as a ransomware attack because they're trying to collect money? Is it somebody doing it because they want to collect sensitive information, expose it because they want to do something else in terms of business and competitive? Where are they coming from? Who are they attacking? What types of resources and who are they attacking? What is the importance of the types of resources attacking? For example, this vulnerability attacks is against web servers. So web servers are the vulnerable points, but not just web servers. Maybe they're attacking all of them, but they might be trying to attack specific ones for specific purposes to gain access to other bits of information. So we need to collect all this information from all these different places to really get that understanding, do that interrogation. What makes good information? It needs to be reliable. It needs to be current. It needs to be things that I trust. Information that I know that is coming from a credible source. If I'm a police person and I have a confidential informant and they're a drug user and they're whacked out all the time, they may not be giving me good information all the time. Maybe they're just giving random information just because. I need to put some sort of reliability score to the information. Of course, I need to also know that it's current. The information I'm getting, is it relevant to what's happening today, or is it something that happened 3 years ago? Is this a vulnerability that existed because it worked on Internet Explorer version 7 from a dozen years ago? Is this a Windows NT vulnerability versus something that's more recent with Windows IIS or Red Hat Linux or something else? We need comprehensive data. We need data that can cover as much as we can. We need to blanket the world in terms of the data collection to be able to get the best visibility into what is happening. We need to know what is happening way out in one location, attacking something in a different location that's unrelated to us, because you know what? The next thing we know, there's an attack coming towards us that's related to what happened there. We need to have intelligent analysis of this information. Like I said, the analytics is critical. We need to take all this data because there's going to be a ton of data coming in. And this is the problem with this concept of big data. And I'll put air quotes around that big data as well. This is the problem with big data, because big data is just about a ton of information coming in. We need to do some sort of analysis to make heads or tails of it. And ultimately, that analysis needs to give us actionable results. It needs to tell me, here is a credible threat. Here's what you need to do to mitigate that credible threat. I have this web server vulnerability. What can I do to mitigate it? What is already being done to mitigate it? What is my next step to stop this attack from happening to me, to my organization, to my resources, to my IT infrastructure? This is important. So ultimately, And driving towards the theme of this discussion, community-driven threat intelligence, we want multiple data sources. We want data sources from all these different locations to give us these different points that we can correlate. So, for example, now I'm going to introduce the concept of what we do with Snapt with a product that we have, NovaSense. But this can be a more general concept where we can have honeypots. We can look at the logs on our HTTP-based web applications. We can look at locations, geolocation. We can look at the network statistics. OSINT, open source intelligence. And we'll talk about that a little bit because there are some people tend to have thoughts about open source intelligence. We can look at the SSH demons in terms of people logging in and off of various servers and applications. And of course, there can be proprietary intelligence as well. So you're getting logs off your firewalls or your routers, your switches, your other vendor provided devices. Within Snapt, we have our web application firewalls, standalone ARIA firewalls, and cloud-based Nova firewalls. And we actually use that to get, for all the consumers who use this technology, we will collect that and create a general pool of information about what's happening globally from this proprietary intelligence. So let's talk about a couple cases of this data, just to give you a little more explanation. Honeypot. What is a honeypot? It's kind of what it sounds like, is a pot of honey. It's something that's really sweet and enticing, something that you want, something the attackers want. So what you do is when you build your network and you have your web servers and your database servers and all these other components, you put out a system for the sole purpose of attracting the attackers. So it looks enticing. It has open vulnerabilities exposed on purpose, possibly, because what you want to do is you want these attackers to find these honeypots, and they're going to attack these honeypots. And now what you get out of that is you learn what are the attack methods these attackers are using. How are they attacking your systems? What type of information are they trying to extract when they do attack and compromise your system? Who is the attacker? Where are they coming from? What is their IP address? Or are they attacking other systems? So these honeypots are these enticing little gems on the internet that are designed to give us information, intelligence from the attacker with nothing sensitive or that we really care about exposed on these devices, on these servers, on these systems. So honeypots can be a very cool way of getting information from the attackers about their methods and who they are without compromising your systems. The other piece I want to talk about is OSINT, open source intelligence, because a lot of people in the cybersecurity world will say, well, OSINT, that's not very good. I mean, it's all out there. But that's the point. It is all publicly, OSINT, open source intelligence, is basically information from publicly available sources. And there's a lot of cool information out there that you collect. In fact, if you look at how hackers work in terms of their reconnaissance and intelligence gathering, it's primarily based on open source intelligence. If I'm a hacker and if I'm going to hack your organization and your network, I'm going to do my Google searches. Who is your company? What is the IP address of your website? Who are employees? What are their email addresses? What are their phone numbers? What type of systems are your operating systems or your servers running? What potential vulnerabilities are in those operating systems? How can I get to all of this information is publicly available. So they're going to do their primary reconnaissance using open source intelligence. And then from there, they can get into the more personal and private where they do the phishing attacks, where they send emails or might call you and say, hey, I'm from IT. I need to reset your password. What's your password? I had to get the information to get to that point. And that's all based on open source. So open source intelligence is extremely valuable to the hackers and correspondingly is extremely valuable to you as a cybersecurity professional. And of course, we have the proprietary intelligence. These are, again, what I like to call my confidential informants. It can be a broad community of sources. It can be different types of sources. It can be a myriad of information coming through. For example, going to my Snapt NovaSense example in terms of how we do this community-based threat intelligence, is we have all these web application firewalls deployed around the world by many different types of organizations. And we're going to collect information on what threats they're seeing, what threats they're blocking, and boil this all together. These are my confidential informants, these web application firewalls. And I'm going to collect this information, and I'm going to say, okay, I see this possible attack or anomaly happening in this location for this community, and I see something similar over there, and I see something over there. So now I'm going to correlate and say, okay, there's a consistency. Or I see this one person accessing this, trying to access this website through this tool, and that website through that tool, and this website through this tool. I'm going to correlate that. So now I can provide some very rich intelligence, is very reliable because it's coming from these informants that I trust and I know about, and there's context about it, because it's not just random data saying, I see this threat in this location at this time. I know who and why and how it's deployed in terms of, because they are part of my organization, my infrastructure, my community. I know that this web application firewall is in front of this web server for e-commerce or for manufacturing or for something else. So I can correlate this information with some context in terms of how and what this information means. So this becomes extremely valuable. In fact, this can be one of the most valuable pieces of information you can get if you get good information. And this leads to the concept of this zero-day threat detection. How do we detect zero-day threats? Well, number one, you need to be in real time or close to real time, because a zero-day threat is going to be happening in a active situation. So we're getting information from all these different sources, and we have to do the analysis. We have to do the analysis to understand, okay, we have a threat. We have a possible threat. And let me give you an example. Excuse me. So I've been mentioning this recent vulnerability that we've been talking about, this Log4j vulnerability in Apache web servers. And it's a logging mechanism for web servers. And the problem is it's open source code and lots of organizations use it. And lots of actual vendors actually use it and roll it into their products. So what does this mean? It means that this open source code is out in a lot of places. Again, millions of web servers are affected by this vulnerability because someone discovered this vulnerability because for whatever reason, the coding wasn't done completely up to snuff. And there's this ability for people to send requests that go outside the normal bounds of what this software package is designed to do, where now they can run remote code. So you can download or execute remote code onto the system, and this basically opens up the door wide open for you to gain full control of the web server's operating system and collect data, use it to hijack other systems, to make changes, to do all sorts of bad things. And it was discovered or announced, the vulnerability, about a week ago or so. But even before it was announced, taking the example of Snapt's NovaSense threat detection, we were collecting information from our web application firewalls about potential threats related to this Log4j vulnerability, and saying, okay, this isn't right. This isn't normal. I'm going to perform this action, and the different action ended up being blocking the attack because it was not normal, and now we can correlate it. So we've been able to look at all the attacks even before the announcement. And we would say on order of about 98% of the attacks trying to exploit this vulnerability were blocked, even before the vulnerability was announced. Now, that last 2% were because there were some side cases of specific types of attacks trying to do specific things. And then so now we can see that, and we can say, okay, we see you trying to circumvent the standard blocks, and we can apply a policy quickly and easily to stop that last 2%. So now we have the ability to block every single attack against this vulnerability. But even before that, we were blocking 98% of them, which is what most of the people are doing it because it's 98%. But we are able to detect threats based on the behavior, based on this community of information, to come to a consensus that there's something not right. And if we don't trust it and it's not right from a cybersecurity perspective, block it. So it requires this community of information and the analytics to really properly do a zero-day threat detection for your environment. And this is especially true in the network architectures that we have today, because in today's world, when we talk about multi-cloud, public cloud, virtualization, like I said at the beginning, my systems, my servers, my applications are not sitting in a confined data center with a firewall in front of it, with a router in front of it, going to the internet, and I know the exact path. Now I have applications that are in public clouds. They're in Amazon, AWS, they're in Azure, they're in Google Cloud, they're in private data centers, they're running on VMware, they're running on Hyper-V, they're running on Zen, they're running on Red Hat, who knows what, they're running on containers, so they're running on Docker, there are microservices, I'm running Kubernetes. There's all these different pieces now to the puzzle, so it's so hard to track and understand what are the vulnerability points without using this community-based model for intelligence gathering and threat detection. It is, in my mind, essential for us to adopt a more open standard, just like how we say in the world of IT and security. Security should not be a single point of control in your network. You should apply security every single point in the process, in the path, where possible, as applicable. And this is true for the information gathering as well. Gather it from as many places as possible, because the more information you have, the more reliable and more efficient you're going to be. And of course, I keep on talking about this, the analytics. Big data requires big analysis. You need to have the secret sauce of the proper analytics, and you can't do it manually. I hear so many horror stories from companies, from customers, from organizations where they say, I have security implemented, I have firewalls and IPS, intrusion prevention systems, and all these devices installed. And I'm getting literally thousands or even tens of thousands of alerts per day. And it's just unmanageable. And it's true. It's just crazy how much information and how many alerts they're getting. Because the problem is, most of those alerts are not relevant. So it's all a matter of boiling that down, using some sort of tool, this analytics, artificial intelligence, machine learning, to be able to get the context, to correlate, to create a subset of those alerts, because a lot of them are going to be related to each other. Of those 10,000, 8,000 might be interrelated to one thing. So how do you boil that down to things that become actionable intelligence? Things that you can act upon to say, yes, we have a problem with X, and it's affecting these systems and these environments and these locations and these types. Here's what you can do to mitigate that threat. Or even better, here's what we have already done for you to mitigate that threat. I'm just letting you know. The analytics is what makes or breaks or differentiates one system from another system. This is what makes some intelligence organizations good versus great. You need to have good analytics. So to give you a little more detail of how, for example, we do it with Snapt NovaSense. Here you can see on the left-hand side, we have the NovaSense Threat Intelligence. This is my engine that's doing the analytics and collecting the information and giving us information. And you can see on the top, I have my various threat sources. Like I mentioned, I have my open source intelligence. I have my locations, IP addresses, for example, my web apps, my networks, my daemons, and of course that proprietary information, my Snapt web application firewall sending me really useful information. It all goes into this NovaSense Threat Intelligence system. And this system then churns, and you can see in the middle of that little wheel going around. And we are going to provide information in terms of potential threats, and we're going to categorize it. What kind of threat is this? Is it botnet? Is it a malware? Is this somebody doing a denial of service attack? And give it some sort of score. So score means the higher the score, the more dangerous it is. Give you some sort of score and give you some sort of threat projection in terms of what it means for you and what you should do. What is the actionable intelligence you're going to do? And of course, cybersecurity should not be an island. Each component should not be sitting by itself. I should not have 10 security systems and have to manage 10 different consoles and 10 different information systems. I need to integrate it all. I want to integrate it with my SIEMs, use API so I can connect to other systems like log management, ticket management systems, use DNS. For DNS, I might do a real-time black hole listing. I export files, do whatever the case may be to really protect myself in terms of integrating with my other tools. So we really want that system to properly manage the threats from the information and give you actionable intelligence. And that's what we're trying to do at Snapt NovaSense. And we're really helping to drive this community-driven threat intelligence to really get to where everybody wants to be. We want everybody to use these types of threat sources to be able to get this type of intelligence. So, small pitch here. I'll leave it at this. Snapt Nova is designed to be fast and accurate because you need real-time and actionable intelligence quickly and easily. And when I say easily, I really mean that simple, because we know cybersecurity is complicated. Those 10,000 alerts a day, those other pieces, all the systems you need to manage, all the different types of attacks and all the different systems you have to, it's really is a nightmare. So you want something that's simple, easy to plug in and really get instantaneous results. And of course, it needs to meet your budget, and bottom line, it needs to work for what you're getting out of it. You need to get that return on investment. So it's a really cool solution, something you want to look at. So to summarize everything that I'm saying here, and it's hard to summarize because I could speak for days on this topic, is number one, when we talk about cybersecurity, this concept of community-driven threat intelligence, number one, get more information. Get more data sources. Get more useful data sources that are timely, that are reliable, that can provide you information and context to determine what the threats are for your resources. And that also means that you need to get relevant information, not just random bits of data about things. What did I eat yesterday? I don't care. From a cybersecurity perspective, I don't care. I don't need that information. What is the relevant information, and how do I take that relevant information and then translate it through these analytics to really give me the actionable information to be able to do something proactively, reactively, to be able to mitigate these threats so that I can sleep at night. That is what we want to do with this community-driven threat intelligence. That is the goal of bringing this together and trying to educate you or talk about this so that we can look at and open our minds about what types of options do we have for getting information to really improve our security posture and our policies for this cybersecurity model that we're trying to build. So if you want to learn more about NovaSense, you can go and get a free NovaSense account. Go to this website, novasense-threats.com/register. Get a free account, start looking at it, playing with it, and if you want to get more information or talk to us, you can certainly contact us at Snapt. The Snapt information is there. We have our Twitter handle. We have our Instagram, as well as the email that you can contact our sales team to get more details and talk to some people about what this is all about. And lastly, I do want to mention, we do have 2 more upcoming webinars related to this topic. So next month, January 20th, how to integrate community-driven threat intelligence into your SIEM. So how do we plug it into all these other tools, and what does it mean, and what is the value? And then on February 17th, why artificial intelligence, this AI concept, is key to community-driven threat intelligence. I talked a little about it today, the analytics, the importance of it, and we'll do a deeper dive on what this means and why it's really important to this information and to what we can do with community-driven threat intelligence. So go to that website, register if you haven't registered already, and hopefully we'll get more conversations and more great questions. So at this point, I want to move it to the Q&A section, and hopefully we have some great questions that we can answer for you here.
Okay, well, thank you so much, Frank. We do have a few questions in the chat. First one, is there an integrated plan or process that I can follow to minimize the threat-driven society?
So that's a really good question. So I talked about the model of this intelligence gathering and everything, but in terms of an integrated plan or process followed to minimize threat-driven society, something I didn't mention that I probably should have, and something I'll probably mention in the future webinars, and we can talk offline about this further, contact me, is this concept of the MITRE ATT&CK framework. MITRE is a non-governmental organization, it's an open community, and they've developed this framework called the MITRE ATT&CK framework, MITRE, M-I-T-R-E, ATT&CK framework, and it goes through all the components and steps that an attacker would do to get into and compromise your system, from reconnaissance to attack to infiltration to compromise to exfiltration or extracting the data. And is a great framework that a lot of security companies are starting to leverage and look at. And I recommend taking a look at that and see how you can apply and look at the different pieces, components of that framework, and apply it to how you would do things to minimize the threats in your organization and infrastructure. So that's a great question.
Okay, thank you. We have another one right here. Cybersecurity framework has to be holistic in view, in detection, and visibility. Could you please explain how the cybersecurity framework has to gain practice?
Yeah, holistic. I love that word, because cybersecurity framework absolutely has to be whole. And when I say holistic, I mean a few things. Number one, I mean to try to be, as much as possible, vendor agnostic. So you want to be able to leverage no matter what vendor you're using, because the problem is so many vendors have proprietary solutions that only work for them. We need to open that up more, because cybersecurity is not about protecting against a specific vendor vulnerability or vendor capabilities, but it's protecting my entire environment, my holistic ecosystem, my IT ecosystem. And the second piece, when I think of holistic, is I want it to be covering multiple concepts in terms of technology. So cybersecurity is not just about the firewalls and the intrusion prevention systems. Cybersecurity includes the other services, the routers, the switches. Cybersecurity includes the applications, the databases, the backend, the middleware, all these other pieces. And it all comes together and they all work together as a unified thing. So me as a user, when I connect to an application, I go through all those components, but as a user, I don't care, because it all works and it just provides me the information that I want, and as well, it should at least. And cybersecurity is making sure that that happens in a reliable, confidential manner. And it has to incorporate all these different components and different pieces. So again, I love the word holistic, because now when we're talking about community-driven threat intelligence, I want a holistic view of the information on the internet and technology world that could be affecting me from a threat perspective, so that I can take these different pieces, whether they're physical pieces, whether they're news reports, logs from my firewalls, information from my web application firewalls, from other people's devices, open source information to give me this thing. So how do we gain and leverage practice? I think it's because we as the end users and the consumers really need to see the value and help drive the value to push this, to say we need to get to the point where we can get this information through the APIs and other sources. We see it in other technologies happening slowly, but coming together as a holistic ecosystem. Something in the AI world, I'll just mention this and then we'll move to the next question, is something in the AI world that I use a lot and other people use a lot is we want to be like the Terminator movies, Skynet, where there's self-evolving, self-healing, self-modifying artificial intelligence that keeps the network happy. And I like to say my version of Skynet is the happy, human-friendly version where it doesn't go out and try to destroy every single human on the planet, but it's designed to make the world better. That's what we want to do in an ideal world with all this information, with the analytics and the AI and everything else, is be able to collect all this information and do things properly in a way that we feel is appropriate based on our individual or company-based policies. So how do we get that? I think we just need to continue to drive and push and see the value in it as the end users and force or get all these other organizations to jump on board.
Okay. What is Zero Trust security model in cloud?
That's a big and broad question, and that's probably 3 more webinars for us to do to answer that question. Zero Trust being this concept of complex IT architectures and moving to the cloud and virtualization. And like I mentioned earlier, our applications don't sit in these predefined locations and these predefined paths, and they just sit in all these other places in the public cloud, private cloud, disaster recovery. And so the problem is, if the application is all over the place, how do we apply our security policy to make sure that only appropriate people access these applications? That trust model. How do we apply the trust model for this? And the problem is that if it's all over the place, we need to create a trust model that's also quote unquote virtualized, that is out there, that can apply a trust and then apply it to something else that's not even in line. So in the traditional old school world, I go through a firewall, I go through some sort of authentication system, and once I pass that firewall or gate, it's like the old medieval castles. I get past the big gate, now I get inside and I have access because I'm trusted. The problem is in today's virtualized and cloud world, multi-cloud world, is that gate and that moat and that wall does not exist anymore. And these applications, instead of being one castle, is lots of little huts all over the countryside. So now I need to have some sort of method to trust to be able to get to these places. So I'm going to have some sort of badge or ticket or some sort of token to say I can get to them. It's a complicated problem. It's not easy to answer. There are multiple solutions. But ultimately, how it applies to this is that community-driven threat intelligence becomes even more important. Because now, with these things all over the place, we need to get better information in terms of who is authenticating, who's trying to authenticate, who is trying to access without authentication. And the only way we can probably get all that information is using this community-driven intelligence gathering.
All right. Looks like we're close on time here, but I think we have time for one more question. From an ESG, environmental, social, and governance perspective, is there any data that indicates how community-driven threat intelligence practices have impacted an organization's footprint?
That's a good question, and I'm not sure I'm sure there are reports and data about this. I don't know what there is in specific that I can offer you today, but I can tell you absolutely that this community-driven threat intelligence is beneficial. If you apply it right, it makes a lot of sense, and they have been able to impact the organization. And when you say organization's footprint, I'm going to say in terms of their cybersecurity stance. Have they been able to mitigate more threats? Have they been more effective in protecting the resources? Have they been more effective in reducing the time required to react to and respond to threats and attacks that have compromised systems? And the answer is absolutely. And again, I'll use the great example of this Log4j vulnerability, this web vulnerability, where in our case, we've seen a 98% blockage before the vulnerability was actually announced, and then further extending that after it was announced. So from a governance perspective, governance perspective, from a business governance perspective, absolutely. When we talk about environment and social, I think it becomes a little more challenging in terms of how do we apply it from an environmental and social perspective. I think it depends on your business practices and how you apply them. But in terms of overall IT infrastructure, absolutely is designed. It has proven results today in terms of your capabilities, because in general, the more information, the better. So I think that's a good question. I think there's a lot more things we could do to look into that.
All right, it looks like we're at time, but before we go, I would like to thank Snapt for sponsoring today's event, as well as Frank for the very informative discussion. Just a reminder, the seminar will be available on demand starting tomorrow, so please feel free to come back and review. Have a great day, and thank you all for attending.